calculus students. So we are going to continue our notes on the derivative rules. So far we have learned the power rule, product rule, quotient rule, and then today in class we learned the rules of trig. And we finished a couple examples. I want to go and remind you of those. So the examples that we worked on were these ones down here. And one thing that I want us to now consider as we are doing these problems is thinking of our rules. And determining before we even start a problem, which rule is it that we are doing. So for instance, when we do this problem A, we are just performing a trig derivative. In part B, when we did this problem, we are just doing a trig rule. F was a little different. So in F, there was a trig inside of this, but the primary rule we were following was the quotient rule. And inside the quotient rule, we performed the trig derivative. Okay? So I think that this is a helpful practice for you to help you determine how to start a problem is by labeling it as one of our derivative rules. So I'm going to have you do that. So go ahead and pause me and label each of the following problems that we have not done as power, product, quotient, or trig. Go ahead and hit pause. Okay, and then, so, oops, that's not power. This one is just another trig. This one, even though we're multiplying times 5, is just another trig. In E, I am multiplying two functions together, so this is a product rule. And in G, this one's a little tricky because you can see I have both a product and a quotient, but if we think, but basically we have a product inside of a quotient. So the main rule we're going to use here is our quotient rule. And the product rule just gets done within our bigger quotient rule. Okay? So after doing that and knowing like what is the primary rule we're going to apply for the rest of these, I want you to pause me and give those a try. So hit pause and give those a try. Okay, I'm trusting that you paused. You need to try these on your own. You better not just be copying me, because copying me isn't going to help you at all. But for those of you who do need to check, here are the answers I got. So for our product rule, remember you can always label things as u and v, then find u prime and v prime, and then multiply them properly. So multiplying across like that. And then for this quotient rule, remember I said we did have to use the product rule inside of it. I will zoom in on this one because there's a lot going on in this problem. Sorry, you probably ran out of space. So when I take the derivative of high, d high, I have to use my product rule. So I used my product rule to get the derivative of what's high. So I did x times the derivative of sine plus the derivative of x times sine for that d high, and then d low is negative sine, and then I combined all these things together into my quotient rule. So low d high minus high d low over the square of what's below. I multiplied everything out, and then what's kind of cool is that this term, so x cosine squared and x sine squared, you know cosine squared and sine squared added together equal 1. So x cosine squared plus x sine squared add together to equal x. So that is a cool simplification trick if you weren't aware. Okay, cool. So let's refer back to our derivative rules. We have these so far. And just like I talked about in class, we are going to learn 2 more. So we're going to learn like an exponential. Oh no, my pen. There we go. Exponential. That right now we're just going to learn e to the x. E to the x is what we're going to learn. And then we're going to learn our natural logs ln of x. Okay, so we're going to learn these 2, and they are very easy. They're very easy, much easier than these, which remember you do need to start memorizing for your quiz. We're going to move on to these. So, here are the first batch. Here. So derivatives and integrals of expressions with e. So up here in this table, we followed the same strategy that we followed for sine and cosine. Is we made a table for x, e to the x, and then they showed us the values of the derivative of e to the x. So we were supposed to do this on the calculator, but I filled in the table for you. Aren't I so nice? So here's the table for you. And I want you to look at the values that we get for e to the x and the values that we get for the derivative to e to the x. Do you notice anything about those 2 rows? Aha, yes, great job. They're exactly the same. So what this is implying is that the derivative of e to the x is the same as e to the x, which is exactly true. So the derivative of e to the x equals e to the x, right there. I don't want you to get this. This is kind of something extra. Don't worry about that right now. Mainly, I just want you to know, oh my gosh, they're the same thing. Cool. So then we can solve some of these examples. Okay. I'll do A and B with you, and then you can try C and D on your own. Again, before I solve them, I'm not going to label them with which rule I have. So power, product, quotient, trig, exponential, or natural log. Because we could, not natural log, yeah, or exponential. Okay, so what is like the main rule that we're going to use? So looking at A, I see that I'm not multiplying 2 functions. I just have this single function, e to the x. So this is just, I'll just write, this is an e to the x problem. I'm just going to use my e to the x rule. So y prime, I'll keep my coefficient. The derivative of e to the x is just e to the x. Isn't that great? Yay. And we can use this rule inside of more challenging rules. So here I see I have x times e to the x. This is indeed a product. So this is a product of 2 functions. So I'm going to have to state what my functions are. So I have my u and my v that I'm multiplying together. So I need my u prime, which is 1, and my v prime. So the derivative of e to the x is just e to the x. And then I'm going to do my product rule. So I'm going to multiply those things together. So f prime of x equals x times v prime plus v times u prime. And that is it. I could rewrite that. I could factor out e to the x if I want to, if that is a more satisfactory simplification. Yeah. Okay. I will let you try these on your own. I'm going to give you a little hint because D's strange. So if we were to categorize these according to our derivative rules, we would say that C is a quotient. So this one is a quotient, which is obvious. D is not an exponential form because it's not in the form e to the x. This is x to some power. So this one is actually just a power rule, and I want you to try that. So pause me, give those two a try. Okay. And when you come back, here are the solutions. Should look like this. So quotient rule, I labeled my high, my low. I found d high, d low, and filled it into my low d high minus high d low over the square of what's below. Again, I factored out that e to the x to simplify it a little. And then this one was just a power rule, so I just need to bring down the power and then subtract 1 from whatever the power was. This one was a little weird because I put e up there to trick you, and I don't know, maybe I did. But your final answer is just e plus 1 times x to the e power. That's it. Okay. So now let's learn our last rule, our natural logs rule. So one thing that I do want you to hopefully notice is that for both of these, my exponentials and my logs, we are very particularly learning like an exponential with a base of e and a log with a base of e. So we can kind of call these my base e rules. There are other rules that we will learn later if we have an exponential with a different base or a log with a different base. They get a little bit more complicated. We're just going to stick to our beautiful base e rules, which are nice and simple. So an exponential with a base of e is nice, as is a log with a base of e. So a log with a base of e is my ln. Okay. So again, we're making a table. This time we just made a table with x and y prime. So a reminder that the y prime that we're finding is d dx of ln of x. So we're looking for what is the derivative of ln of x. And so I'm going to give you a second to look at these values you get and try to find a pattern. So the first thing we get is an error on the calculator. You can think this is like undefined. So when we plug in 0, it's undefined. If we plug in 1, it's 1. Plug in 2, 1/2. 3, 0.333. When we plug in 4, 0.25. And so on and so on. So what function does this look like? Okay, if you look down, you can see it right here. So basically, the relationship here is the reciprocal function, which is y prime equals 1 over x. So it's 1 over x. So the derivative of ln of x is 1 over x. This is the main thing we need to remember, which is why we got undefined for 0. Don't look at that yet. Okay. So let's go over some of these examples together. Okay. I'll highlight this again for you. Alright, so again, we want to always be considering which rule are we using. Power, product, quotient, trig, an exponential, e to the x, or a natural log. Which rule is it? So this is a minus sign, by the way. So for this one, I have my sum and difference. So for each of these, we can consider them as like two different functions. For the first part, I'm just using my ln rule, and then this one is just a little power rule, a basic, super basic power rule. So for this problem, we do them separately. So the derivative, I will just keep my 2, and then the derivative of ln of x we just talked about is 1 over x. And then the power rule here, the derivative of x turns to 1. So we could rewrite this nicely as 2 over x minus 1 is my derivative. And And then right here, I see I have an ln and a power, but they're both within this quotient, so this is overall the quotient rule with just an ln and a power rule inside of it. So with my quotient, I need to say what's my high and what's my low, and then my d high and my d low. So d high is the derivative of ln of x, which is 1 over x. D low is the derivative of x squared, which is 2x, my power rule. Okay. Once I have all those things, I will sing my song. So the derivative f prime of x will equal low d high, that's low d high, minus high d low, so d low is 2x, over the square of what's below. Yeah. And then I can simplify a little bit, so x squared times 1 over x is just x, minus, can't really simplify here, I'll write it as 2x times ln of x, and then the denominator becomes x to the 4th power. There it is. So I do want you to do try example C and D on your own. First, let's label them though. So go ahead and write down what you would label these as, and I will do the same. How would you label those? Which derivative rule? Which derivative rule? I will label them as, this is a product of two functions where I have an exponential and a log in it, but it's a product of those two. And this one, even though I'm dividing, since I'm just dividing by a coefficient, this is not a quotient rule. This is just my ln rule. So I have a natural log rule. That's all that one is. So pause me, try these two on your own. Okay. You did it on your own? All on your own, right? Remember not to just copy me. I don't like when people just copy me. Okay, so here's the product rule for that one. We end up with that. And then over here, remember this is not a quotient rule. I can just factor out the coefficient, and it's just the ln rule. So when I take the derivative down here, it's 1/5 times 1 over x, which is 1 over 5x. Okay. Alright. That is it for these notes. Come to class prepared to practice these tomorrow. Bye.